Hi, welcome to this knowledge clip on how to apply geoarchaeology in the archaeology field course. My name is Sjoerd Kluiving. I'm Associate Professor in Geoarchaeology and Anthropocene Studies.
And I'm Tariq Sheikh, PhD candidate in Landscape Archaeology in the Mediterranean Fieldwork Project, What Went into the Melting Pot.
In this knowledge clip there are two parts. At first we will introduce you into the basic geology and soil science theory that is directly applicable to your fieldwork area. At second, we will go into the activities and skills training that are part of the module, for which we will also use movie clips to demonstrate from past years in the field course. Now we want to draw your attention on this image showing three different presentations of the same sediment column. At the far right you might recognize directly the archaeological stratigraphy, meaning how you divide layers according to the nature and age of archaeological remains, also called the archaeostratigraphy. You can notice from the Paleolithic to the Roman times. The far left column shows the lithostratigraphy, meaning the natural, geological and sedimentological layering. Note that you use color, lithology and other specifications as massiveness to describe the column. Finally, in the center, we see the soil stratigraphy described. The Roman numbers 1 to 4 show 4 different periods of soil formation through time. In overview, this figure shows some of the complexity of geoarchaeology we are teaching in this module. Now we will focus on the first two columns.
The Netherlands is a country known by its topographic highs and lows. Usually we refer to the Pleistocene in red, example the Push moraines and the South Netherlands areas, and the Holocenes, the low, in green, for example the Northern and Western Netherlands areas and the coasts. The geological processes such as land ice, rivers, sea, wind, and periglacial processes, peat formation, tectonics, and humans form the geological landscape of the Netherlands. The location of Orla in the High Netherlands is indicated. In this field course in Orla, we will focus on the influence of wind and periglacial processes, the anthropogenic processes, and to a lesser extent, the influence of faulting or tectonism. Typically in a sediment, we can distinguish between sedimentation or sedimentary processes, geogenesis, and the soil formation, pedogenesis. The difference between the two is that geogenesis describes dynamic processes that are changing landscapes through the power of rivers or the force of wind, for example, resulting in sediment layers. Pedogenesis, on the other hand, reflects stable landscape conditions that allow for the formation of soil horizons and thus soil formation. This clear distinction means that soils always develop within the sediment and never on top of it.
The first definition is by Joffe, 1994. The soil is a natural body of animal, mineral and organic constituents differentiated into soil horizons of variable depth, which differ from the material below in morphology, physical makeup, chemical properties and composition and biological characteristics. And the big question is, of course, why do we find certain soils in one place and other soils in other places? So, is there a coincidence? Or are there perhaps other causes and steering factors? So, from soil forming processes, for example potsolization, you will result in soil horizons, bijvoorbeeld humus inspoelings horizons, influx horizons, which gets you soil bites like potholes. And that gives us the Cleopatra, the climate, the organisms, vegetations, parent material, time and relief drainage. These are the soil forming factors which determine in fact the processes, the horizons and the soil types.
Coring is teamwork, and that's what you'll be doing in the field. Luckily at Orla, you'll be encountering some fairly friendly sediments. But why should you go coring? Well, for many reasons. for landscape reconstruction, to trace archaeological find spots, to have insight in the conservation of archaeological traces, and finally, to add the third dimension to your archaeological sites.
So what does a geomorphological map tell us about the field course area? There are fluvial periglacial deposits, cover sands, like Aeolian ones, snow meltwater deposits and meltwater river deposits. The red arrow here on the map shows the location of the fieldwork sites. Lithostratigraphy concerns the subsurface sequence of sediment layers. Soil overprints the sediments, except at the anthropogenic soils where you can have both. Here you see that in prehistoric times a podzol soil has developed on the far left and partly overprinting the Pleistocene cover sand. This soil has been exposed for many millennia. Since 1500-1600 AD, the farmers have been using and adding material to the soil with manure and forest material to such an extent that anthropogenic topsoil is formed, varying in thickness between 50 and 100 centimeter. It creates so-called double soil, as you can see here, with different ages and therefore different archaeological expectations.
The textural triangle explains the relation between the amount of sand, silt, and clay in a soil sample. Lutum is clay in this figure. According to the percentage of clay, silt, or sand, we can distinguish between different lithological textural descriptions, like weak silty clay, KS1, or clayey sand, ZKX, for example. All soil samples that you take can be subdivided according to this triangle. In the field, you will observe and record how characteristics such as grain size, texture, and color change throughout the stratigraphy.
The learning goals of the Geoarchaeology module are description of sediments and soils, the correlation of corings and interpreting these in a cross-section, addressing research questions. So what do you do actually? You're coring and recording, working out in cross-sections, and also has a first attempt to approach the research questions. And then the questions, what do you submit with the end report at the end of September? These are core description forms in teams of 2, with a maximum of 4 cores, a movie clip in teams of 2, and a cross-section with 2 teams. And all research questions will be addressed in the end report.
Your research questions are: what is the geological history of the research area? Which soils are and have been present in the research area? Is there a relation between the ditch system and the natural environment and subsurface? And does this relation indicate a function of the ditch system? And finally, what is the degree of conservation of the site given the geological and soil scientific conditions? To conclude this knowledge clip, we repeat that sedimentation represents dynamic processes that are forming new landscapes, while soils represent stable landscape conditions that have already been formed. Sedimentation does not happen at the same time as soil formation.
Finally, we come back to the 3 different observations of the same sediment column that we have seen before. From the left, the natural sediments are first. Overprinted on these will develop the soils. And finally we see the archaeological traces that are left behind during various stages of the sedimentation and soil formation. We hope you have enjoyed watching this knowledge clip.
If you have any questions, please email us, or we'll see you in the field.